Hey y'all, welcome back. So this is not your last lesson this week. You have one more lesson, but actually this is the last lesson you're going to hear from me because I'm going to be sending you a different video link to watch a YouTube video for lesson 108 that talks about transformations. Okay, so it's the last time you'll see me this week until our next Zoom meeting. But we're going to talk about area of complex shapes. So like last time, we did perimeter of complex shapes. I believe that was in lesson 103 was about perimeter of complex shapes. So we looked at those shapes that look like they're two shapes put together. Or they look like they're one shape that got a hunk cut out of it or something like that. Okay, so they're kind of funny looking shapes, but we had to first find any missing sides using the properties that we know about the shapes. Okay, and then once we found the missing sides, then we had to calculate by adding all the sides up to find the perimeter. Okay, so we're going to be looking at similar shapes, but our process is going to be a little bit different because we're going to be finding the area. So just to recap, remember, if we've got a figure, let me just go ahead and pull this one up so you can see what I'm talking about. If we've got a figure, here, let me go ahead and pull. Just kidding, I'm just going to show you because I thought I had the figure next, but it's not. So we'll just show you. If I've got a figure, we'll just say like this, okay? And then I want to find the perimeter. Remember, perimeter is the distance around the outside, okay? So we add up all the sides on the outside, okay? But then if I want to find, so that's perimeter. Then if I've got another figure and I want to find the area, remember that is the space on the inside, okay? So area is talking about how much space it takes up on the inside, okay? We reviewed that last time or the time before too. I think we reviewed it recently. So anyway, just a little recap on perimeter and area. So now let's talk about the process for finding the area of a composite figure. So when we're finding the area of a composite figure, I've given you a little acronym here to help you remember, okay? So we're going to call it DAC, D-A-C, okay? So to find the area of composite figures, I want you to remember you got to DAC it, okay? So D stands for divide the figure into two shapes. So you're going to take that figure and you're going to divide it into two shapes. Then after you've done that, because remember the figure on its own doesn't look like one shape that we know. It looks like some weird wacky shape. But if we cut it kind of in one place, we find a place to cut it to where it goes into two shapes that we do know, like maybe a rectangle and a square, or a rectangle and a triangle, or a square and a semicircle, something like that. Then we can use our area formula for each of those shapes to find the individual areas, and then C, we combine those areas by adding. And so that will give you the area of the whole figure. So recap, DAC it. Divide the shape into two figures, or divide the figure into two shapes, Find the area of each, combine the areas by adding. Okay, so let's put that into action. So we're going to go here. All right, so here is a little composite figure for us to look at, or complex shape, whatever. I always call them composite figures. The book likes to call them complex shapes. It's all the same thing. So if you hear me say either one, same thing. All right, so let's look at what we know and what we're given here. Okay, so remember, I'm going to write it over here so don't forget. Our process is D-A-C. D stands for divide. So we're going to divide the figure into two shapes. So I'm going to do that. You can actually do it more than one way. I'm going to choose to do it right here. So I'm going to divide my figure by putting a little dotted line right there, and that divides it, if you notice, into a rectangle here and a bigger rectangle here. Okay, so now that I've got my figure cut into two different rectangles, I need to find the area of each. That's my A. Find the area of each. Okay, so area. All right, so I've got rectangle number 1 and rectangle number 2. I'm going to use labels so that I make sure I remember to find the area of both. Okay, the more organized you are with these problems, the better, because that will help you to ensure that you do all the work necessary and get to the answer you're looking for. Okay, so be organized about it. Set up one spot for the first rectangle and one spot for the second rectangle, and then set up your formula. So how do I find area of a rectangle? I know every single one of you is saying it right now. Length times width. Very good. So length, area equals length times width. Area equals length times width. All right, so rectangle number 1, we're going to call this one rectangle number 1, and we'll call this one rectangle number 2. How about that? So if we look at rectangle number 1, we can see that we are given a length and a width. So we've got a length of 7, a width of 4. So I'm going to go ahead and plug those in. So I've got a length of 7, a width of 4. All I'm doing is multiplying those. So my area of that one, 4 times 7, is just 28. Which is 28 centimeters squared. Don't forget that. So then let's look at rectangle 2. On rectangle 2, I'm given the length, but problem, I don't see a width here. So let's look at what we do know and see if we can determine what it is. So if I know that this whole distance here is 6, okay, and I know that this distance over here is 4, remember, this 4 right here is going to correspond with this side over here because that's a rectangle, so that's a property of the rectangle. Opposite sides are congruent. So if this piece is 4 and I know that this whole thing is 6, then that could help me determine that, 6 minus 4 would actually make this side right here 2. So that tells me that my length of my short rectangle is 3 and my width is 2. So I'm going to be multiplying 3 times 2 on this one, which 3 times 2 equals 6 centimeters squared. I am almost done, but I have one more step, and that is to combine. So now I'm going to combine my 28 plus 6, and that gives me 34 centimeters squared. It's area, so my answer should always be in units squared, even when it's composite area. That doesn't change that, okay? Awesome job, guys. And you know what? I think that is all we have for this one. So just remember your steps. Divide, you're going to DAC it. Whenever you get a composite figure that you have to find the area of, you're going to DAC it. Divide your figure into 2 shapes. Find the area of each shape. Then combine the areas to get your total. Okay? If you remember those 3 steps, you're golden. Great job, guys. Happy homework.